Welcome back to another LeetCode slash NeetCode grind. So yeah, let's go. Today I'll be going into the linked list section because I find linked lists exciting and more manageable, so to speak. And so we'll be doing those questions again. I came through this post from Arpit, who's this amazing guy. Amazing, he gives some amazing posts. Please check him out. And he talked about something about erasure coding, which is interesting, where he talks about how S3, I mean, if you're storing data on S3, and if you want that data to be, to be available, even if a disaster were to be struck on the data center it exists, you just keep multiple copies of that data everywhere, in different locations. But that would scale up very badly, and then that would be pretty much not possible because you have to, for one data, you'll have like 3x the storage, which in the long run would take up storage so quickly. So I think we'll learn about this a bit, right? We'll keep this here. Actually, just learn about erasure coding. So look up erasure coding. I even saw a video of someone working at Dropbox talking about erasure coding, so we'll talk about that. Anyhow, so let's get started. And I think the first thing I will do is let's get YouTube, and you already know the mix I'm gonna use, which is brown noise. Just brown noise, put it around 20. Cool. And so the question I was worrying about was linked list cycle detection, which was pretty much, there's a cycle that is the list given to you may or may not contain cycle. It's your to tell whether it contains cycle or not. So the way I solved this was using this pretty much, right? Pretty much this basically of um, we'll have a list of essentially all the visited node, and based on that we will check if that means it's pretty much the equivalent of storing, it's pretty much equivalent of storing each of this address into an array over here, which is the visited node, and checking if this has been visited before. It yes, true, else we return false. So this is quite simple, but the question says, can you do this in O of 1, like in constant memory? That means you'll use a two-pointer approach. But I don't know that, and I actually gave a lot of time doing this question, and in some other channels in my previous video, you would have seen that. In the discussion page, someone said to me, Ki, this is a knowledge-based question. So if you don't know the solution, you will most likely will not be able to figure yourself out. So I'm gonna watch a video explanation and try to find it ourselves. Let's go. You guys can hear it just a bit. I've increased this
Hey everyone, welcome back, and let's write some more
just a bit.
LeetCode today. So today let's solve linked list cycle. I know that we solved a problem that's pretty much a harder version of this exact problem, but in this explanation I'm going to explain why the tortoise and hare algorithm on a linked list cycle, why exactly it works, and why exactly we know for sure that it's a linear time algorithm, because I think most people just kind of glance over why exactly this is true. So I'm going to go.
And before this, the reason the way my interpretation worked of this is, if you have a linked list, like if these are the nodes in a linked list and it does not have a cycle, if you have a left pointer and if you have a right pointer, the left pointer will always be the left of the right pointer and right pointer will always be the right of right. But if you have a cycle, this position will overlap, so you will know that, but I don't know how to put that in code in a sense, so I guess.
Over that today. And you can see that this linked list problem is another problem from the blind 75 list, a list of 75 problems we've been working through and tracking on this spreadsheet. The link to the spreadsheet will be in the description if you want to take a look. We are not quite done with this sheet yet, even though we have done pretty much most of the difficult, medium, and hard problems on this list. So basically we're given the head of a linked list, and we just want to determine if there exists a cycle in this linked list or not. And basically the definition of a cycle is if at some point, you get
Yeah,
to a node and you keep following the
it
pointers
says,
along that node, eventually you'll get back to the same node. And if we get back to the same node, we'll be able to do it again and again and again, basically an infinite loop. So we return true if there's a cycle, we return false if there's no cycle. Now the first idea you might have is just start at the beginning, keep going to the end, keep going, and eventually let's say that this -4 actually pointed to null. In that case, we know, okay, we got to the end of a linked list, right? So in that case, we return false, no cycle. And that's always going to be the case. So if there's no cycle, it's really easy to detect that there's no cycle because eventually we reach null. But if we don't reach null, right, we go along this node and we get back to the same node we already visited, but for some reason we can't detect that. So then we go to the next node, and keep doing that. And from our perspective, we're just going to say, okay, it's just a really long linked list. Eventually we're going to get to null, right? But that's not going to be the case. If there's a cycle, we never get to null. We'll never break out of this loop. So we really have to determine a way to detect that we're visiting the same node twice. So how can we determine if we're visiting the same node twice? Well, we start at the beginning like usual, and we maintain a hash map or a hash set in this case, where basically we take every
I
single
just give
node
the
and
note.
we take the node itself and add it to the hash set after we have visited this node. We don't add the value because I think in this problem there could be duplicates, right?
Duplicate.
Like the same value could show
Yeah.
up in an object. And so in that case, we're going to take this to a node, visit the same node. Way that we can do this without using a hash set, we can do this in O of
Of one
one
space
memory,
room.
and that's the slightly complicated algorithm. I'm going to show you that algorithm, and I'm going to show you exactly why it works. So the idea is simple. We're going to start at the beginning.
Before he explains the actual algorithm, which is the root cause of me not understanding things, let me just understand what all things I have to do to. Yeah, so pretty much stack one was easy, like it was not that tough. Threesome is something that I will have to think about. Never know what is easy. Easy. This is to group anagrams to some. Yeah, I think we're doing it the right. We're on the right track. Okay, sorry, chat. I'll do this.
Beginning of the linked list, but we're going to have two pointers this time. We're going to have a slow pointer S, and we're going to have a fast pointer F. And you may have seen this algorithm before. It's a pretty simple algorithm once you know it, but I'm going to again show you why exactly it works. So the slow pointer each time is just going to be shifted by 1. The fast pointer is going to be shifted by 2. So it's going to be here. And so originally they do start at the same position, but we're going to look at every position after we've shifted it. And so what's either going to happen, obviously the fast pointer is faster than the slow pointer. So if there is the end of a linked list, right? Like for example, this points at null, the fast pointer is of course gonna reach the end of the linked list first. So if we do that, then we can return false. No cycle exists in the linked list. But if there is a cycle, do you see that this fast pointer and this slow pointer are going to meet again? They're going to meet at the exact same position. And if they meet at the exact same position, that must mean that a cycle exists. So I'm just going to run the simulation, and then I'm going to show you why it's always going to be the case that these two are going to meet if they ever reach a cycle. So we just take one more step with S, right? We're only shifting it by 1. F is going to be shifted by 2. So first we're going to go to 4, and then we're going to follow the link and reach back to this position, right? The 2 position. So clearly F made a loop. F has gone through the cycle. And so far we've shifted each of the pointers twice. And so we're going to do one last shift. S is going to reach the 4. And our F from over here is going to be shifted twice again, and it's going to reach the 4 as well. So at this point, we're going to see, yes, the slow pointer and the fast pointer have met each other. How could it be possible that they met each other if the fast pointer was going twice as fast? Because they were in a cycle, and eventually the fast pointer, no matter where they start, slow is here, fast is here, eventually the fast pointer is going to catch up to the slow pointer. Let me show you why that's always going to be the case and why
The slow will catch up with the fast, you meant to say.
it's
Okay.
going to happen in linear time. So let's say this is our cycle, and I'm not drawing it as a linked list. It's some kind of circle, right? And it's a cycle. And let's say we're moving clockwise in this cycle. First thing to notice is, do you know that every gap, so let's say, the distance between slow and fast, that's going to be some integer value, right? It's not going to be a decimal. It's going to be an integer value.
That's gonna be.
And this portion is also going to be an integer value because the entire length of the cycle is going to be an integer value because linked list lengths are integer values, right? This is an integer 1, this is an integer 2, also 1, so the entire list is length 2, right? So we're dealing with integers here, not decimals. So we're looking at the case where the slow and fast pointer are at different positions, because obviously if they were already at the same position, we're inside the cycle, they're at the same position, then of course we know we're going to return true. But it could be possible that they're at different positions. Any arbitrary position is what I'm choosing here. And we know that the slow pointer on one iteration is going to make one jump, right? The distance it's going to move is 1. We know that the fast pointer is going to move a distance of 2, right? So clearly, in our simulation, eventually the fast pointer is going to reach and surpass the slow pointer. But why is it true that they are going to meet each other at the exact same spot?
Um,
Let's just give this distance an arbitrary value. We know that the fast pointer will catch up to the slow pointer, and this is the distance that it's going to have to travel in order to do so. This is our gap that we have to close. So let's say the length of this gap is 10. If we move the slow pointer by 1, we're taking the gap and increasing it by 1, right? If the slow pointer gets shifted by 1, we increased the gap. But then the fast pointer is not going to quit. It's going to move by 2 as well.
to
So
-2.
when we move the fast pointer, we're taking the gap and closing it by 2. So we're saying +1 minus 2. And you
And
see
this
how
uh,
this evaluates
to
10
10 minus
minus
1.
1 is
That's
going to be 9. So on a single iteration
that's actually okay, buddy. That's just beautiful. This is beautiful.
of the loop, the distance between the pointers is being closed by 1. So then how many iterations is it going to take for the fast pointer to reach the slow pointer? Well, of course, whatever this length happens to be, right? Whatever that closing distance happens to be, whatever that gap happens to be, how big could this gap possibly be? It could only be the entire length of the list. So, let's say the fast pointer is over here where this distance is 1. So then the remaining distance is going to be the entire length of the list. Let's call that n minus 1. So then how many iterations is it going to take to get this to equal to 0? Of course, roughly n. So that's why the overall time complexity is n.
Okay, that's actually a beautiful explanation, to be honest. That's actually very good. Um, yeah, so they start from here. Okay. Okay, so they're pretty much there. So yeah, so right, so they pretty much have some value differences over here, and then this is pretty much how much.
The length is the distance, where n is the it's going to work. Pretty pointer at the same position, and the next time that they meet each other is how we know we've detected a loop. So obviously they're at the same position now, so we don't want to say that there already exists a loop because we don't know that for sure. And we're going to be shifting our fast and slow pointers while fast and fast.next is not null, because we need to make sure that fast.next is not null, because remember we're shifting fast by
They're starting off at head, right? Okay. Okay, and while fast and fast dot next. Okay, while fast because you need to make sure कि fast ही null नहीं है, because हम लोग अभी start कर रहे हैं इसको यहाँ पे slow and fast है, right? So we need to ensure कि because we have to jump 2 times, we can only jump 2 times. There's something over here, so fast is not null, and fast dot head is also not null. And so they're starting at head, and then we will do fast is equal to fast dot next connects, and slow is equal to head connects, like something like that.
2, meaning that there does. So if it does that, then out.
I mean, if that means okay, fast and fast or null is not that the case. मतलब not head null मतलब um, it's null और मतलब यही null है हाँ तो that means कुछ नहीं है एक है okay हाँ makes sense return false yeah that makes sense
Outside of the loop, we can return false, meaning that there does not exist a cycle. But on the inside, we're going to check if there is a cycle. So we're going to take our slow pointer, shift it by 1, slow.next.
hmm. Yeah that makes sense so essentially slow becomes slow dot next and fast becomes fast dot next fast dot next is this dot next right
Take our fast. Now, if they meet each other, we can say if slow ever reaches fast, then we can return true. There does exist a cycle, and you could pretty much write this loop as a do-while loop in a lot of other languages, but I don't think Python supports that. So the solution is really as simple as that: linear time, constant space. You can see that the solution works and is efficient. So I hope this was helpful. If it was, please like and subscribe. It supports.
that's actually a good uh, that's actually good that's actually quite what it's trying to say. Let's assume you have a linked list that is an cycle right ये एक cycle है now what is the length 1 2 3 4 5 length है now initially slow and fast will point to this right and हम लोग उसको क्या करेंगे we'll do slow को we'll push once over here and fast ko we will push once over here. This will initially set them off, so to speak. Now, if fast wants to catch up with slow, it has to cover up this distance, which let's just assume is some value of. Now, ये distance कितना है? ये distance 1 है, so this distance is 4. 1, 2, 3, 4. So at every iteration, slow will move by 1, so it will plus 1, and this will minus 2. So at every iteration, this will be somewhat equal to 3. And so this is always going to be linear because they'll be offsetted by some value which they have to catch up, and this catch up will be O of n. Right, let's try to do this. Right, again we will first initialize a slow and a fast, which will be head comma head. They'll both be pointing to head. Now while fast and fast dot next, because that makes sense, else we will return false. What this initially tells us is while fast and fast dot next, we don't really care about ki fast dot next is null. Even if it's null, then that's great. What we do care about is ki while fast is not null and fast dot next is not null, right? Because that this is important, right? What we will do now is we'll do slow is equal to slow dot next, because you know fast dot next is not null, and then we will do fast is equal to fast dot next, and if slow is equal to fast, we will return true. If they are not, then we will just go ahead with the yeah, this should work. Is this 61 milliseconds just some artifacts? Um, uh, it's 57 now. Yeah, pretty much. Let's look at the discussion. Okay, interesting. Interesting. Let me just fix my network for some reason. What's wrong? Apparently, nothing was wrong. So crazy. Yeah. So I understood the reasoning behind them. Like the reasoning was key. What we do is, and it also makes sense, so to speak, right? If it does not contain the what do you say, the fast will eventually reach null, and then we'll have to exit out of the loop. But if our loop does contain, right, this is pretty much that it. This will eventually, I mean, we're assuming that, but if it comes over here, slow is over here, then fast is over here, because they both are closing the distance. So we go slow over here, one, two, fast over here. Yeah, so pretty much in any cycle this will work. Okay, interesting. And we say while fast and fast dot next is not null. Hmm. While fast, the current head, right? And because that's what's required, and that pretty much lines up very well for our solution as well, which is interesting. Okay. Merge two sorted lists. This is also one of my favorite questions, and I did this in college. We had linked list pretty much in C, and yeah, they were pretty much like, we're going to. Uh, I think I know how to solve this, but yeah, you're given the heads of two sorted linked lists, list one, list two. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. Um, I think one of the best things you can say is if list one and list two, like if, this is very, and then we can do another thing when the both of them are not null, right? Right. If, I mean, right, this is, right. So if list one and two both are none, return none. Now, if only list one is none, then return list two. If only list two, and this could do pretty much a lot of things, but let's just do none. This might pass few tests. Like if the test they do put those things, they might pass few tests. No, just run the test cases. Yes, you see, it does run our test cases that we actually intended to. Obviously, there's a better way of doing this, but yeah, that's better off. So yeah, okay, let's take a very simple example of the test case itself, which is 1, 2, 2, 4. Okay, so we have 1, 2, 4, and then we have 1, 3, 4. Okay, so they want it to be like 1, 1, 2, 3, 4, 4. That is what they want the okay. So let's have one pointer over here. So we'll have one, we could say like F pointer over here, and we could have a second pointer over here. We'll compare both of them. So if okay, so there are three things, right? Fast could be greater than S, fast could be equal to S, or these are the three conditions that can happen, right? If fast is less than S, right? I mean, if they both are equal, then what should we do? We should give at least one of them. Doesn't really matter. Both of them are equal. We could take any one. Let's say we take fast, and we take fast wala, And so I think the let's not take this example because this example is pretty much effing with our mind. uh okay, वो example दिया है, that's kind of sad. Okay, let's have first and second, right? So let's do something like let's solve this in 30 seconds, by the way. Let's have first, which is equal to list 1, and we'll have second, which is equal to list 2, right? So let's just say if first का value second के बराबर हो गया, what we would want to do, we can change anything, but we could say something like, okay ठीक है, that means we will pretty much इसको हम लोग we'll take first का value, पहले तो we'll push first ahead over here, and we'll take this value and we will pretty much snitch it to that s वाला value, and now हमारा s हम लोग यहाँ पे दे आएंगे, बिकॉज टेक्निकली अब क्या हुआ है, ये यहाँ से अब यहाँ पॉइंट कर रहा है, राइट? अब हम बोलेंगे, अब देखिए अब ये 2 कम है, एक्चुअली एस यहाँ पे ही रहना चाहिए टू बी ऑनेस्ट, राइट? सो नाउ इसका ये मतलब है कि एस को पहले मतलब ये इधर आना है, तो मतलब वी विल मूव अहेड ओवर हियर, राइट? एंड वी विल से वेल यहाँ से यहाँ, एंड अब सेकेंड का ये होगा, so this will point over here and this will become our second. uh hmm. Also the thing is they're not common, right? Right. The other thing is, how do you put that in words? So hmm, uh, this is our first pointer and this is our second pointer, and we want to keep moving this while, right, while f is not none. Okay, so okay, we'll compare both of them, right? We'll compare both of them, right? The only we will compare them if it's not none. um so we will say, okay, so f का वैल्यू कम है s के वैल्यू से, तो so this means कि जहाँ जिसका कम पे चल रहा है, we will do f dot next is actually equal to s, and before we do this we will actually set the next वाला, the next element to be judged is f dot next, so we know कि this is the next element that we have to judge, ठीक है? बोलोगे f dot x is equal to this, इसका ये मतलब होगा कि now this loop will be cut over here, and अब ये यहाँ connect होगा, right? And this also means कि now that we will, this also means कि our head node will actually start from the node जो सबसे कम है, so it'll start from f का node essentially, right? And s कहीं नहीं जाएगा, s वहाँ पे ही रहेगा. Now we come again and check, okay, now क्या है, तो we see that s dot valve, right? So s dot valve कम है f dot valve से, so again जहाँ यहाँ पे हम लोग वहाँ पे change करेंगे. What we will do is now s, so we'll do s का next हम लोग save करके रखेंगे, तो ये next है, right? We'll do s का next is actually equal to यहाँ पे अभी f है, so this cuts this relation and pretty much goes to over here, right? And ये आपका f भी हो गया, right? And s dot next ये अपना नेक्स्ट कंसिडर कर दिया, दिस इज आपका बन जाता है हमारा एस। अगेन फिर से हम लोग कंपेयर करेंगे, ये यहाँ पे आएगा एंड देन वी कम एंड वी चेक, ओ वाओ, तो देन ओके दिस यहाँ पे आएगा। सो हाउ डू वी कंसेप्चुलाइज दिस इनटू वर्ड्स, लाइक हम लोग इसको कैसे करेंगे? सो so let's do one thing. While first and second is not none, what we will do is let's make it very simple. We will do if f dot valve is less than second dot valve, we will do something, um, right? Elif second dot valve is less than first dot valve, we will do something, and else pretty much means first dot valve is equal to second dot valve, and we will do something over here, right? And so first dot valve is less than, the thing is we want to keep this pointer wherever the first smallest we get, right? So I mean I need to make a way कि whenever we find the smallest first element हम लोग उसको एक head pointer दे देंगे, हम लोग इसको ही return करेंगे. How do I do that? It's a very good question. You should ask those questions, right? So if first dot valve is less than second dot valve, right, मतलब हमें first का कुछ change करना होगा. First dot valve का value less है second dot valve के value से. फॉर एग्जाम्पल इसी केस में 1 and 2, तो क्या 1 लेस हुआ तो हमें इसका राउटिंग बदलना होगा. तो इसका राउटिंग बदलने के लिए हम लोग बोलते हैं फर्स्ट ऑफ ऑल नेक्स्ट इज इक्वल, ओके, नेक्स्ट एफ इज इक्वल टू फर्स्ट डॉट नेक्स्ट. पहले हम लोग उसको सेव कर देते हैं फर्स्ट डॉट नेक्स्ट वाला, देन वील से फर्स्ट डॉट नेक्स्ट इज एक्चुअली इक्वल टू सेकेंड. इसका ये मतलब है कि अगेन इफ आई टेक दिस एग्जाम्पल, इफ आई ट्राई टू मेक दिस क्लीन एंड टाइडी, this is our linked list, and currently this is our first and this is our second. Now again this is null, right? What I'm saying is while this first and second is not null, हम लोग क्या करेंगे, फर्स्ट डॉट वाल्व लेस है 1 लेस है 2 से, यस यस, देन वी कैन से नेक्स्ट एफ. सो ये हम लोग इसको कर दिए नेक्स्ट, राइट, हम लोग इसको नेक्स्ट कर दिए, एंड फर्स्ट डॉट सेकेंड इस वाले को हम लोग हटा के हम लोग ने यहाँ इसको राउट कर दिया, बराबर, यहाँ पे हम लोग ने इसको राउट कर दिया. अब आई विल से दैट आवर फर्स्ट बिकम्स नेक्स्ट एफ, राइट. अब मैं बोलूँगा अब मेरा एफ यहाँ पे आ गया, परफेक्ट, अब मेरा यहाँ पे आ गया, ठीक है. अब हम लोग नेक्स्ट इटरेशन लूप का चलेगा. नाउ विल सी कि सेकेंड डॉट वाल्व, जहाँ पे अभी सेकेंड का बदला ही नहीं, सेकेंड डॉट वाल्व इज लेस देन दैट. सो अगेन वी विल से समथिंग लाइक नेक्स्ट सेकेंड इज इक्वल टू सेकेंड डॉट नेक्स्ट, राइट. सेकेंड डॉट नेक्स्ट मतलब अब ये हम लोग का नेक्स्ट वैल्यू हो गया है, एंड वी विल से कि सेकेंड डॉट नेक्स्ट इज इक्वल टू फर्स्ट. नाउ सेकेंड डॉट नेक्स्ट इज इक्वल टू फर्स्ट, ये हम लोग का हट गया, देन ये हम लोग का फर्स्ट हो गया, and then we will say second is equal to next s. So now this becomes our s, ठीक है, this becomes our s. now we come again loop में चले फिर से, तो अब loop में फिर से ये आया, तो अब इसमें क्या होगा, second dot f यहाँ पे आ गया next, राइट, एंड फर्स्ट डॉट नेक्स्ट अब हम लोग का सेकेंड में इधर राउट हो गया, तो ये वाला राउटिंग ख़त्म होके यहाँ पे राउटिंग हुआ, एंड हम लोग का फर्स्ट यहाँ पे आ गया, राइट, हम लोग का फर्स्ट यहाँ पे आ गया, एंड इसके बाद हम लोग का फर्स्ट नल हो गया, तो ये बंद हो गया, ये बंद ही हो गया. तो दिस इज वर्क. लेट अस अज्यूम अगर स्टार्टिंग में ही दोनों में, फॉर एग्जांपल अगर 1 2 है, 1 3 है, दिस इज आवर फर्स्ट, let's just change the loading. This is our first, this is our second. Now अगर दोनों ही equal है, right? So दोनों equal doesn't really matter, हम लोग कुछ भी कर सकते हैं. तो for example मैंने कर दिया next f is equal to first dot next. So मैंने बोल दिया कि ये मेरा next हो गया, right? अब मैं करूँगा first dot next is equal to second. तो अब first dot next को मैंने यहाँ पे डाला, इसको मैंने हटा दिया, right? एंड मैंने अब राइट अब क्या करूँगा, मैं बोलूँगा फर्स्ट इज इक्वल टू नेक्स्ट एफ, राइट? सो नाउ फर्स्ट इज, अब ये फर्स्ट आ गया, राइट? अब हम 2 और 1 में हम कौन सा वैल्यू, ये वाला वैल्यू रन होगा, राइट? दिस इज हमारा नल हो गया, राइट? दिस इज हमारा नल हो गया, राइट? नाउ हमारा ये वाला रन होगा, सेकेंड डॉट वैल्यू विल बी लेस. सो नाउ दिस विल बी आवर नेक्स्ट वैल्यू एंड हम लोग इसको राउट फिर करेंगे यहाँ से यहाँ तक, राइट? एंड देन वील डू दिस इज आवर सेकेंड वैल्यू, राइट? ग्रेट, राइट? अभी हमारा सेकेंड वैल्यू हो गया. नाउ विल कम डाउन अगेन एंड विल चेक, ओके वेल एफ का वैल्यू कम है, सो ओके this chat the only issue now is where is the head pointer, right? So we speak like who is, like what I'm trying to say is this first value or whatever the first instance is that will take in, so to speak, the head. We need to give a head pointer, right? And the head pointer depends कि कौन छोटा है. अगर हमें पता चल गया ये 1 है ये 2 है, so this will be the head pointer, right? अगर ये कुछ भी है, we need to set up the head pointer only once it is set, we don't have to do anything, right? So we'll say something like head is equal to null. अभी के लिए मैं none रखूँगा इसको. If head is none, then we will set head to be, in this case, first dot valve, right, next dot f, उसको next को सेकंड डालेगा एंड उसको आगे बढ़ा दिया, right? If head is none, then set head to first. This is a banger of a अगर head none है, right? But after this one assignment head none नहीं होगा, and then we can return head. Let's see this runs. Okay, it doesn't run on this. This is interesting. Oh wow, so our output was this. Oh, okay. So we have 1 1, so mostly this triggered, right? Right, that means, okay, so that, okay, wait, pause. 1 2 4 none, 1 3 4 none, right? Right, so both values are same. What do we do is we say like, okay, this is our first and this is, actually let's just change the color, this is our first and this is our second. What we say both of them are equal is we do this as to be our next, right? So this is our next f, right? And we do first dot next is equal to this, so we say first dot next, instead of this it's gonna point to this, righty, and then we change this to first f. Great. This loop then runs again, we compare them again, this turns out to be, this is the case, right? Second dot valve come hai. So we do next of valve is we say, okay, this is next s, and we say second dot x is pretty much wherever this is, and इसको हम लोग हटा देते हैं, right? And if head is none, head is not none, and second, then this becomes our second. um hmm. मैं देख गया गलती क्या है. No, I know it will fail when I actually try to pass it. मुझे पता है it will fail in that sense. um it will fail, I know that, because it will have varying length strings, and for that it will not pass. Yeah, exactly. So we have list 1, 5, and 1, 2. So it should actually be 1, 2, 4, 5. So yeah, we have to figure that part out also. So okay, so right now this is our actual answer. This works, right? This is working, and this is very horrendous though. But yeah, let's see this, if that how we're supposed to make that work. So we have 5, we have 1, we have null, right? We have 2, 4, and null. And so this is pretty much, that is it. So what we do is we will, so basically this is less, right? So this is second. Now second का value कम है, so we will do this as next. Oh, oh, this is way too complicated. My head just blasted. I don't know how to solve this. Um, okay, I guess I'll just stop this because right now I've studied too many problems, and also my Excalibur says ki beta you're pretty much revolving. Okay, let me just how do I clear this? I have so much stuff on this. How do I clean this? Okay, that's much better. Um, okay, I guess I won't do this because my mind is just not hitting at the moment, and yeah, I just won't do that because I just let's just focus on the problem that we just solved right now, right? Um, Crazy. Yeah, so today also we did something which is interesting. Okay, let me just try to understand again because my mind is just going wild. Okay, so we have, let's say, a linked list that contains nothing, right? So if we have slow and head, so first thing is you set them up on their initial position. While head, while fast, and fast dot next. What that essentially means is it's trying to say while fast, so this is not null, right? And also this is also not null. The opposite could be key that this is null or that this is null. In both of the cases, that means it's not a cycle, and that's why we just pretty much return false. But in the other case, we have to check, right? So that means we have this and we have something over here. Now we don't know what this is. This could be null or this could be a list. And we come here and we say, okay, this is slow and this is fast. Fast will go boom boom, will go null. And then we have slow. And at every iteration, we check, are we in some value null? right? And why do we do that? It's because fast is moving 1 2 fast यहाँ पे, and this is your slow. If we can't really move ahead over here, right, this is null, it's not gonna be. So we have to check that, and that's why we do that, and we do slow is equal to slow dot next. And this relative ordering doesn't really matter, I can put it over here as well. It doesn't really change it, you have to just move it once, right? Doesn't really change the test case in that sense. um so yeah, that's the thing, right? This doesn't really matter, I could do this because we're just moving it at once. You can assume it's like moving it at once, right? It's not going to change anything, right? So that's what I'm trying to say. Okay, so that does just, and then again, the explanation he gave was very fun. And the way in the thing is that this is a cycle, and right, let's say after initially this is slow, one, one, two, and this is fast. Now, in order to catch up, this let's say is one, and the remaining is, what is the remaining? One, two, three, four. 1 2 3 4 5, this is 4. So the f needs to catch up by s by 4, but every time s moves, right, but this 4 every time s moves gets incremented by 1, but when s moves gets decremented by 2, so this comes up to be something like that. So that is linear, right? This will always be some value of n minus 1 essentially, because after setting it up initially, the differences between them will be 2, will be 1. So that's why it's no of n minus 1, which is taken as a linear approach problem. And again, thank you. The solution is actually very fun. Like, this is very funny solution, to be honest with you. Like, yeah, it's off n. Crazy. Yeah. Well, I guess that was fun. We have to revisit this to, right? So revisit. What is the question name? Linked list cycle detection. We have to follow this up one more time. Um, that does two questions. This question was a that was something. What is this reorder list? What is this question, chat? Why? Why? Why do I have to do this? Uh, chat. Uh, um, chat. Why? Why are we here to suffer? Remove end from the end. Yeah, so how do we do this? Um, yeah, so pretty much this is okay. The way this works is we have 1, 2, 3. So this is 4. So this is 4. यहाँ से 2 रुकना है, मतलब यहाँ से आपको 2 इधर रुकना है. So after 1, 2 iteration, ये first second you will be actually at the point where you want to remove it. And so they say to remove this in O of n, we can find the length of the list, right, in O of n. So I mean, right, so let's do something like this. L0, right, let's do something like current is equal to head. Now while current is not equal, is not none, we will do L plus equal 1, and we will do current is equal to current dot next, right? And I think this will help us a lot in the sense key. I'll just show you. If we say something like this will work, right? L of 0, current is equal to head, while current is not none, we will do L plus equal 1. So if current is not 1, this first one 1, right? Current dot next. So if L is equal to 0, uh, return head. Else we'll figure something out. Else, I mean return none, to be honest. Right, कुछ है ही नहीं तो. The test case was this. Okay, now how do we do that? Okay, no, wait, we will solve this. We'll solve this. Don't worry about this. We will again say current is equal to head, and what we're gonna do is uh, so let's say we're gonna do 2, and this has 4. So 4 minus 2 is 2. So 1, 2, and we reach this. We don't want to reach there, we want to reach before that. So we would want to do something like, we would start the counter from here. So we'd say 1 and 2. So I would do something like L minus 1, because now it makes it 1. So we'll say while current is not none, and L is because okay, right now L is what? Right now L is 4. um, right, actually what we want to do is n, right? So now we have this minus 2, which is 2. We're gonna do one more right at. So what we do is we just go, okay, yeah, we just go one more time. So we will just do something like this, right? So pretty much अब आ गया हम लोग का 1, right? So while current dot this, and we could also say while this is greater than 0, um, we can do current is equal to current dot next, and L minus 1. And so what this happens is now pretty much it figures out that it's 2 minus 1, 2 4 minus 2 2 2 minus 1 1. So now we it's one pair, and while current is greater than 0, we come over here and we do L minus, so this becomes 0 and this stops, and now we are stopped behind it. And so we could pretty much what we could do now, and okay, let's see यहाँ पे क्या होगा. 1 minus 1 minus 1. So minus 1, L is equal to this. Now क्या L greater than 0 है, क्या minus 1 greater than 0 है? नहीं, तो current head पे ही रहेगा, right? But we are now stopped at somewhat where we know where we want to be stopped, and what we will do is we will say current is current connects, is right because we are over here, right? So we want to do current connects is pretty much this. So we can say current connects is equal to current connects dot next, and then we can return head. Right? This is like one of weird solution, but yeah, let's see. Yeah, so it passes case two, none type, and I know that was a mistake. So what's happening is like 1 2, and we're gonna reduce this, right? And so let's say we have, okay, so this is 2 minus 2, which is 0 minus 1 minus 1 minus 1 here. So what we will do as, so this is current, we do current connects uh um hmm if current is still equal to head, that means we will just do head dot next is equal, uh we'll just say head is equal to head dot next, and we will just return next, right? uh right. Hmm. So 2 minus 1 1 1 minus 1 0, so इसकी वजह से it never really increment. Man, I know how to solve this question. Like genuinely do know how to solve this question. um okay, what's even better is we loop through this, we come to the last element, and then we go 1 2, but even that inquires us to do like, okay, let's go there, and this is a singly linked list, right? So we just come, like we just come to the back, and now we start from here. So now they want to know, so we just stop. That could also be a viable solution, to be honest with you. Like, okay, let's try to do that. Okay, let's do this thing that making current go point to the what could n's value possibly be? N value could be 1, so n value will be 1, but if head is none, and we just return none, right? Else return head. Like if head is equal to none, then I'm just saying if that happens, right? If heady none has, right, that could also be the case. But yeah, make current travel to the last node in the linked list, right? So I'll say current is equal to head, while current dot next is not none. We will say current dot next is equal to current. Current is equal to current dot next. Okay, what will this do? So if we have, यहाँ पे आएगा current, it will check क्या current dot next is none, right? यही है ना, right? नहीं है, right? नहीं है, so it comes over here. क्या current dot null नहीं है, it comes over here. तो ये it stops at, but there's no use of doing that because I can't go in previous order. Yeah, that kind of sucks. Finding the length of the list. So we can say current is equal to head while current is is not none. We can do L plus this, L को 0 रखते हैं, and we can say current is equal to current dot next. So इससे हम लोग को लिस्ट का लेंथ पता चल जाएगा, राइट? लेंथ ऑफ लिस्ट, राइट? इसको ऐसे कर देते हैं, much better. Anyhow, right, so while current is not none, we will do L plus equal 1 and we'll do current is equal to current dot next. Okay, हम लोग को आ गया. Cool. So now हम लोग को आ गया कि ऐसे ऐसे कर देते हैं, नल आ गया, ठीक है, एंड ये हम लोग का हेड है, ठीक है. Now when will we told to fumble with the help? Fumble with the help कि अगर ये होगा कि 1 minus 1 0 आ गया, right? That means we have to figure out something with that, because यहाँ पे 2 minus 2 0 आ गया, right? So what that means is something to do with head. लेंथ इतना आप वहाँ से इधर किए थे, 1 2 3 4 and length before it. So that means if length is equal to none, we will say head is equal to head dot next. सिंपल एज दैट, बात बराबर है, मतलब हेड के साथ कुछ करना है, राइट? तो हम बोलेंगे हेड इज इक्वल टू हेड डॉट नेक्स्ट एंड एल्स वी विल जस्ट रिटर्न नन फॉर नाउ, right? It's not passing those tests, but it will pass that test. That means it has something to do with head, right? Because अगर वो ज़ीरो हो गया, मतलब आप जितना हम लोग काटे हो, आप पीछे उतना ही आए जितना लेंथ है, मतलब यू आर प्रीटी मच एसेंशली टॉकिंग अबाउट हेड, राइट? सो 1 2 एंड सो ये वाला केसेस अब हम लोग को टेंशन नहीं लेना है, राइट? अदर देन दोज केसेस जो हैव नॉट टू डू विथ हेड, राइट? से आप लाइक फॉर एग्जांपल यहाँ पे 1 2, सो यहाँ पे हम लोग को कैसे पता हेड के साथ कुछ नहीं कर रहे हो, आप 4 minus 2 करो, ये 2 आ रहा है, मतलब आप यहाँ से अगर काउंट करोगे 1 2, यू आर नॉट डूइंग एनीथिंग विद द हेड, यू आर जस्ट डूइंग समथिंग विद सम अदर वेरिएबल, नॉट विद हेड. अगर आप इसके साथ करते तो कुछ और आता, राइट? सो राइट, वी हैव टू जस्ट, so what we will do is go to the one node before the actual node to be deleted, right? एक नोड पहले जाएगा हम लोग, and we know कि that node exists because हमें पता है कि cz का वैल्यू ही n होगा. So we can say while right, we want to go, so we want to go over here, so once we come here we'll do 1, right? जैसे ही 1 हुआ हम लोग को रुक जाना है, so we'll say something like while l का वैल्यू ग्रेटर देन 1, right? That makes sense. and हम लोग बोलेंगे l माइनस, एंड हम लोग एक और वेरिएबल डाल देंगे यहाँ पे करंट, करंट फिर से हेड, एंड विल से करंट इज इक्वल टू करंट डॉट नेक्स्ट. चलो हो गया. सो वाइल करंट इज इक्वल टू 1, राइट? अगर फॉर एग्जांपल ये आपका होता 1 2 3 3 माइनस 4 माइनस 3 1 होता, तो वाइल करंट इज ग्रेटर देन 1, बट क्या 1 ग्रेटर देन 1 है? नहीं, तो यहाँ पे रुक जाता, right? So now we have stopped 1 before, so we can clearly now say कि exist करता है, and we can say current is current का next is equal to current का next, and we will then return the head after we have done that. उसको मैंने हटा क्यों दिया head? प्रॉब्लम क्या है इसमें? प्रॉब्लम इसमें ये नीचे क्यों नहीं आ रहा है? ओके सो 1 2 3 4 2 1 2 मतलब इसका लेंथ कितना आया होगा? पॉज में चेक लेंथ कितना आया इसका? लेंथ 0 है वाइल करंट इज नॉट नन। इसका लेंथ कितना आया होगा? सो वाइल करंट इज नॉट नन, लेंथ 0 है, वाइल करंट इज नॉट नन नहीं तो लेंथ 1 इधर आया कि लेंथ नहीं है 2, यहाँ पे आया लेंथ 3, यहाँ लेंथ मतलब यहाँ पे आया, चेक किया नहीं है तब उसे, अब यहाँ पे आया तो बोला ओ शिट करंट इज नॉट, करंट इज नन, सो इट गोज आउट राइट. Not to do with head, go to the one node before that. Actually current is equal to head, and then we'll do while L is greater than 1, we'll just decrement L. And so over here we have 2, so 1 2, so we'll just, so we have to basically go one step ahead. तो यहाँ पे अभी क्योंकि ये 4 minus 2 है तो 2 आ गया. Now while L, so while L is greater than 1, yes, so हम लोग ने क्या किया, यहाँ पे पॉइंटर था, हम लोग ने अब करंट को यहाँ डाल दिया एंड अब ये 1 हो गया. क्या 1 greater than 1 है? फॉल्स है तो यहाँ पे रुक गया 1. नाउ अब okay, so I don't know what's wrong over here. Current is equal to head, and while L is greater than 1, we do L minus 1, and we do current is equal to current dot next. And but what's the mistake? I mean, this seems quite buffoony, chat. Like to be honest with you, like you want to delete 3, cool. We do 4. 4 minus 2 is 2. So we do, okay. So we go right, and so this stops over here. Then why is it saying none? And then it says current. If I run this, it'll say that this is an issue. None type has no object. Current dot next. It's pointing there only. I'm so confused. I am so dumb. I'm legitimately dumb. So L will be L minus N. It'll be L minus N. My bad. Yeah, my bad. I forgot this step. I forgot that step. My bad. But let's go. Let's go. That's what we're talking about. So segregation of the problem is very important. If you can segregate the problem, then you can solve the problem. Now this is a bit complicated solution. I wouldn't I wouldn't want you to do this problem solve, but let's go. That's how we do it. That's what we do. That's what we are the goat. You know. Um, yeah, I do tend to overcomplicate things. I will not lie. I do like to just go out and overcomplicate it. Obviously, there's a much cleaner solution of this. What I did is by no means so clean. Uh, okay. I think this is correct indentation. Is this correct? Let's go. Okay, this is correct indentation. I was like, wait a minute, what indentation is this? So if it's just saying if this is none, and you know what's funny is I could most likely do something like this. Move this, um, indent this backward, and also do something like if L turns out to be this, then return none. Like this could all pretty much do the same thing. Yeah, pretty much the same thing. I don't know if the description that tell us that it could be none, right? The number of nodes in the list is ZZ. The number of nodes. Oh well, so this will never happen. That will never happen because it say that the number of nodes will initially will start from one. So we can even remove that piece of code pretty much there without having to worry about anything. Yeah, cool. So I guess there a better way of doing this, to be honest. But the first thing is to find out the list if it has anything to do with the head, right? But yeah, so that was fun doing this. I learned a new technique to finding out a cycle in a linked list. Using the slow and fast method. That was kind of cool. And we did another lead code question by myself, even though I didn't know that how to do that because we learned a lot about linked lists and C and how to delete from a particular position. Thank you for tuning in for another morning session. I guess how you could say that. And yeah, see you in today's another 2 3 videos. Hopefully.